I'm here to talk more about the policy side of this. And, as you get all of these different ideas on what you can work on and the different challenges between math and quantum, how do we actually think about how do we get this stuff funded? Where can you apply for funding? How do you actually get involved in a center that's 400 people big, crossing, different agencies and labs and universities? And how do we think, I think as Jake started talking about the future of the quantum initiative and how we can embed math more explicitly in it so that it's more clear to all of you, like how to get engaged. I work on the policy side for SIAM, so we think about the funding, we think about the engagement with agencies and trying to start new things. Back in 2022, I think it was, we started thinking about quantum and how do we get the applied math community more involved in quantum, and I have to say at the time the committee said, I'm not sure, we don't know. We don't know what the quantum challenges are. We're not sure if people are interested. And so I'm so excited that you're all here because we've come a long way since then. And I think really opportunity to go further. So the big picture federal context right now. So the Biden administration, which is just in its waning months here, has put a big emphasis on emerging tech, following on, as Jake talked about, the Trump administration's focus on the industries of the future. That's really driven by national security concerns. This is not going to change no matter what happens in the election in terms of being a bipartisan emphasis on emerging tech. It's not a partisan area. The CHIPS and Science legislation passed back in 2022, expanding NSF's role in technology, innovation, and partnerships, really set out these 10 emerging technology areas as really critical, and quantum is certainly one of them. And I just have to say the Biden administration's approach across all of these areas is infused around equity, and that means a lot of focus on getting new institutions involved in all of these emerging tech areas, new people, new parts of the country, and making sure that we make connections to communities. And you might think, why are you bringing this up in the context of quantum? It's not like climate or something where you can see a lot of connections, but I think part of the government strategy and part of the next steps is also how do we broaden the quantum community? How do we think about it much more broadly than it's been to date? Now, we are in the midst of elections. Of course, I don't need to remind you of that. And we're also in a bit of a tricky funding situation. So you might know for the past 2 years, we've been living under the Fiscal Responsibility Act. It sets caps for overall funding for the federal government, and that meant cuts to the National Science Foundation in the fiscal year that just ended, and also constrained funding for the next fiscal year that just began, although we're in a continuing resolution through December. We don't know what's going to happen with the funding because it's very dependent on the elections. We're hopeful they'll come back and finish the appropriations after they come back. But what my hope is even in a constrained funding environment, that you all continue, and our funders here continue, to dream and think big. Because actually, the more we can describe what the future vision is and what's needed, the more that's compelling to the Congress to provide more resources to this area and to our field more generally. They are, and I'll talk more about this, they are currently trying to reauthorize the National Quantum Initiative Act that started this whole thing in 2018. There's only a few months left to do that, so we'll see if they can accomplish it. And I really think if past the elections, quantum will continue to be an area of focus. Potentially, Trump could bring back more focus to quantum if he wins the election. As this was an initiative of his first administration, and I think in the likelihood of a Harris administration, probably a sort of similar effort to right now. So either way, I think we're going to continue to have quantum opportunities. I will not dwell on this, as we already heard about a lot of these themes. I just want to note that a lot of the interest in the Biden administration has been on translation and workforce development. And so the thinking around quantum is still very much it's science first, science focused, but also how do we bring in some of these additional translational capabilities? How do we get into the applications areas? Which doesn't have to mean industry, by the way. It could mean partnerships, interdisciplinary partnerships that bring in new quantum applications, but in the basic research realm as well. And there's also been a huge focus on regional innovation. And I'll just flag, so there was a quantum tech hub funded by the Department of Commerce. It's in Colorado. We didn't have a lot of quantum focus in the big regional innovation engine that NSF launched. So I still think compared to other emerging tech areas, we've not seen as much investment in kind of these big regional innovation where we're really driving new industry growth and things like that. So I think that kind of remains for the future. So just a little bit more specifically on the reauthorization itself. So as noted already, the original NQIA, which passed in 2018 and was worked on in 2017, sorry for the error there, is overdue to be reauthorized. So they started working on this last year. The original NQIA had these big efforts at NSF and DOE and NIST primarily, those three agencies, right? And the centers formed, the consortium that Jake talked about at NIST, and all of that continues to be important. So there's no chance, I don't see any effort in Congress to sort of say, oh, let's stop anything that already was happening. There's a lot of interest in how do we say, okay, we had these efforts, they're great, let's continue doing them. And what do we need now? Quantum engineering is a big new focus of the draft bill we have from the House. They're a lot of that just means like they put the word engineering everywhere. So instead of quantum information science, it's like quantum information science and engineering. So it's not like a real change, but I think it showcases the interest in getting outside of sort of some of the initial science and into the engineering that's needed. And then there's also a lot of emphasis in the reauthorization on how do we do more in the workforce space, how do we do more in translation, as I mentioned, and how do we do more in infrastructure. In particular, at NSF, the reauthorization would add a new education and workforce hub, a national hub to better coordinate education and workforce activities. It would also officially authorize the Expand QISE program that is for folks at R2 institutions and minority-serving institutions to get involved in quantum. And it adds new translational programs to be authorized. But then more broadly, the bill looks to add new agencies to the initiative, get other agencies to the table in these interagency coordination that's going on, but also at NASA, major new effort to add new centers in quantum, a lot of it in quantum sensing and quantum communication. And then at NIST to really focus more on quantum sensing and quantum engineering. And at Department of Energy, a lot of new programs as well. I think what you'll notice here, and I've been frustrated by this, is that there's not like a lot that is directly related to math in this list. It's great. There's more education stuff, and sure, yes, we're glad for new NIST centers. And what I've been really hoping, and I think our community has been talking about, is how can we get more mid-level type funding opportunities so that as you go from, okay, I'm an individual investigator, maybe I have my core program funding, where do you go from there when you're not ready to be part of a giant center? And what's the in-between and the middle space? So that's something we're continuing to work on. I just wanted to talk a little bit more about the specific NSF program since we're focusing on recommendations to NSF. About what they should do. So NSF, since the Quantum Initiative began, has continued a lot of different quantum activities. They're currently recompeting their big centers, the Quantum Leap Challenge Institute, and this Expand QISE program has been going on. They also have like a mid-level program called TAX, that's like a $2 million award, and that has a rotating topic. So currently it's in quantum sensing. NSF's also investing a lot in the infrastructure. So they have this virtual laboratory that's under development and competition now. And they also just made a mid-scale award earlier this year for a new quantum nanofabrication facility that's located at Boulder, but it's meant to be a national facility. So that's being built. We also see that a lot of different directorates are doing smaller activities. We've been talking about the interest in engineering, and the engineers have their own visioning group, the Engineering Research Visioning Alliance. So they did a meeting earlier this year on quantum-enabled technologies and how their community could get involved. The Computing Community Consortium, which is an effort of the Computing Directorate at NSF, also has been involved in kind of producing recommendations. So I think this report sits nicely, the recommendations coming out of this workshop will sit nicely alongside those other communities thinking about how do we get engineers and computer scientists more engaged in quantum. And then there's been some new partnerships with the National Institutes of Health as well on how do we think about translating quantum into biomedical applications, and there's like some supplements that one can get right now on that front. The other big new thing at NSF is the TIP Directorate for Technology, Innovation, and Partnerships. And the Engines program is definitely their signature. These are huge, $100 million awards. But there's a lot of smaller stuff going on too. A lot of interest in how do we assess technology pathways and in how investments in technology lead to new ecosystems. There's also interest in getting new people involved in workforce. So if you have an idea of how do we bring students into quantum, like who aren't traditional students, that they have this program excellent for that. And they're also very interested in how do we responsibly design technology to reduce the societal risks. So there's a lot of new programs coming out. TIP did release a roadmap back in the summer that talked about where they're going with their technologies. And I think it was kind of striking. Quantum was not included in their 4 technologies that they want to focus on. I think that's because near term, they don't see as much possibility in quantum compared to, say, AI or biotech, that are much closer to the application side. That being said, I still think quantum will be a part of a lot of their more general programs, and it's in part, I think, up to the community to really think about what's needed to get quantum to that point where it's really at that level where it can be translated and start engaging in some of those new areas. So I hope this has provided just some background for you, and what I really hope is you're thinking of new topics and things like that, really think about the mechanisms. What would help you? What are the challenges? What are the barriers? If I'm excited today, where do I go from here? How can I get involved, and are there types of programs or different things that would help you get involved or would help your students get involved or help you partner? And that would be, I think, really exciting to me if we could come out of this, convening with a great list of recommendations for NSF and of relevance to other agencies as well. So I'll stop there. Thanks.